Applying the correct amount of material is critical for safe winter sidewalk maintenance. Too much salt wastes money and damages infrastructure, but too little salt could leave unsafe, icy conditions. Because sidewalk spreaders are not controlled, metered systems like truck mounted equipment, we don't calibrate them in the same way. Their output is affected by walking speed, material conditions, and how the spreader is operated. So instead of calibrating to a fixed output, we measure how the spreader performs at different settings and use that information to build a rate chart customized to that singular piece of equipment. This chart allows operators to choose the right setting for the conditions without guessing. To get started, we'll set up a small test area, measure the width of the sidewalk and a test length, typically about 50 feet. Mark your start and finish. Multiply width by length to get your test area in square feet. Before starting the test, select a gate setting on the spreader. This is simply your starting point. Each setting you test will become part of your rate chart. Before testing, you should also make sure you're using the same material you'll use in the field, the spreader is set to a specific gate or dial setting, and you plan to walk or drive the sidewalk spreader at a normal, steady pace. Consistency is important because operating speed directly affects how much material is applied. Now, run the spreader across the test section, applying material. Keep a steady pace and stay centered on the sidewalk. After the pass, fully sweep up the material from the test area. Collect as much as possible into a container. The more complete the recovery, the more accurate your results will be. Weigh the collected material, first making sure your scale is zeroed for the container. Then record gate setting, sidewalk width, test length, and the material collected on your worksheet. This spreadsheet will calculate your application rate in pounds per 1,000 square feet using the formula material collected divided by test area times 1,000. This tells you how much material that gate setting applies under normal conditions. Now look at the calculated rate. For this example, this test produced about 7.5 pounds per 1,000 square feet. This tells us that at this gate setting, under these conditions, the spreader applies about 7.5 pounds per 1,000 square feet. Next, we'll repeat the test at other gate settings, both lower and higher, until you have tested for each setting. Understand that we are not adjusting the spreader to hit a specific number. Instead, we're building a reference. Each gate setting we test gives us another data point. Over testing, these results form a simple rate chart that shows how the spreader performs across its full range. Later, when operators need to apply a specific rate, for example, 4 pounds per 1,000 square feet, once that chart is built, operators can select the setting that matches their target rate. No guesswork, no over-application, just consistent results. This process doesn't adjust the machine. It helps you understand how it performs. That understanding allows you to apply the right amount of material more consistently, improving safety while reducing waste.